hoping this works a little better than it did last time, because the video that I used last time didn't record the smartboard. It recorded this computer screen, and so my voice and a blank screen the whole time. So I'm just doing it a little bit differently, so hopefully you can see it and hear me at the same time. Let's go ahead and look at the questions that I had assigned, if you want to call it that, on the bivariate data unit, which is what I believe I did. So from the, I believe it was the sample exam 1, correct? Can you just remind me, since I didn't write them down, shame on me, what numbers we talked about from sample examination 1? And then we'll go through those. Remind me. So go ahead and read them out, Smiley Davis. And then there was from sample examination 2. And which one? 33. And wasn't there something, like one of them was about different data? I forget. We'll have to look. But, well, yeah, ogives. Can I start with that one? Because that one, that was, what was that, 33? The SC examination 2? Let's see which one it was. Might be 12. I'd like to look at the ogive question to start with, just because that really deals with the univariate data section that we talked about before. Yeah, it was 12. So if we could, let's look at that one first. So that was on page 115 of the book. And I'm just going to, again, okay, move that. There we go. To recreate it real quick, just so we can kind of see what we're doing here. Because we talked about that before. 40 looks like it's about here. 60. About here, 80, and something along these lines. So it looks about like that, okay? So it asks in the question here, we have an ogive. Just really quickly, what is an ogive? Do you guys remember? Well, I have to label the axes, right? And the axes, if you look at it, are cumulative relative frequency. And isn't that what an ogive really is? Talks about cumulative frequencies over time, and if they're relative frequencies, it just means they're percentages. Okay, that's really all the difference is. And then we have thousands of dollars of family income here. So just in terms of context, it says which of these income brackets below contain the most families. So I'm looking for the most families. So I'm looking for what in terms of the ogive? Am I looking for a flat part of the ogive? Am I looking for a steep part of the ogive? So let's go back to the question. Why does steepness matter in a line? Because it does. Don't have to raise your hand, just sit. That's all right. Yeah, okay, so if you look at the vertical axis, it goes all the way up to, that's not 0.1 by the way, that should just be 1 for 100%. The steeper the line is, that means it covers more ground. The bigger percentage of people are in that group. So we're looking at the steepest line possible. And I believe the answer would be from here to here, and it didn't really show up super great on my recreation. But if you look at yours, that looks to me like it should be the steepest portion. So I believe the answer to that would be B, as in boy. Okay? Any questions about that? And why steepness was really the key there? Because you want to grow from, like, all, if you look at the horizontal axis, they're all the same width. And so the steeper means it covers more of the frequency in that same width. Think about it from that perspective. Okay. I believe all of the other questions are bivariate questions. Is that true? They should have been. So let's kind of take a step back and go back to sample exam 1. Would you like me to get you another book? I have extras. Oh, you can just share? That's fine, as long as you want to do that. That's fine. But I think I have extras. And everyone in here has one, right? You have one, though, somewhere? Did you want me to get one for you to look at? Okay, I just want to make sure we're on the same, it's fine. All right, so let's go back then to question 5 on sample exam 1. Let me go ahead and just give you the answers first, if that's okay. We'll read the answers. I'll write them underneath. And then if whatever questions you guys might have, we can go over those. So the answer to this one would have been B, as in boy. 27. Dun, 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 is A. And 33 is B. Let's start with those 3. Any of those you want to look at and go over? Y'all tell me. Feel okay with those answers? Take those, go ahead. Number 5, yeah, let's start there. So if we look at question 5, that's a formula question, okay? And so let's just kind of start there. So it says, let's just write down the information that we know. It says the correlation, so I'm just going to write it here, was negative 0.675. The standard deviation of their 100-meter times, so we have standard deviation of the 100 was 0.383, and the standard deviation of their long jumps was 0.469. And it says that the 100-meter time was x, so we can call this the standard deviation of x, and the long jumps is going to be y, so that would be the standard deviation of y. What is the slope of the least squares regression line? So when you look at these things as being given to you, you're given the correlation, you're given the standard deviation of x and the standard deviation of y, hopefully that rings a bell that we're looking at formulas here. Okay, so you have a formula sheet, you should be able to use it. If you have it, you can look at it, but I'll give you the formula that you need to use. And the slope formula, because that is what you're looking for, is going to be r times the standard deviation of y times the standard deviation of x. And so that is, in fact, what you are looking for, and that is the slope. Sorry, so that should be a B1. So that is, in fact, the formula that you should be using, and that's on your formula sheet. And honestly, at this point, it's just plugging and playing. Okay? So we're just going to plug in what we know. We have negative 0.675. And then we'll plug in 0.469 in the numerator and 0.383 in the denominator. And that's why B is the answer. Okay? Any others that you want to look at from those first 3 from sample examination 1? All right, let me give you the sample exam 2 questions then, and we'll look at some of those. Starting with question number 10, the answer was A. For number 12, the answer was B. We already did that one, I think. And then 33 was A also. Lots of A's and B's. I don't think that's a coincidence, so don't think that's normally what happens, but it is totally a coincidence there. Would you like to go over either 10 or 33? Oh, goodness. 10, sure. All right, let's look at that one. I know, sorry about that. All right, let's look at 10 from sample exam 2. We're given a plot of some kind, and it does say it's a scatter plot. I'm just going to do my best to recreate it the best way I know how. Okay, good enough. It is that there's no units or anything. There's nothing really kind of contextually given to you. Doesn't mean that, but pretend like that's a straight line. And it says, what is the correlation coefficient? We should be able to look at our answers, and I'm going to write those here just to kind of see what they are. But we're able to rule out several answer choices simply based on the direction of this particular graph. Okay? When we talk about describing a scatter plot, we did this in class yesterday. What do we have to describe? What kind of words would we use? The strength. So what kind of strength do I have? I wouldn't say weak here. I would honestly say that if I was going to draw the line of best fit, they're pretty tightly fit, right? So I wouldn't say weak. Weak would be like the one we did in class last time where they were really kind of scattered and it was kind of weak. This one to me is a little bit stronger. So I wouldn't say weak. I might say relatively strong. It's not super strong. It doesn't seem like everything's tightly fit. We definitely want to talk about strength. What else do we want to talk about? The direction. And so what kind of words would we use for direction? There's two choices. Linear is the other thing that we want to say, and that's the shape. But what about direction? It's either positive or negative. Okay, that's when I say that, that's what I mean. And in this case, what am I talking about? It'd be negative. So these are the words that you would use. Okay, relatively strong. Remember how I said it in one class, I'm not sure I said it in both, but ly words are bad. When you talk about, was it your class? I wasn't sure which one I talked about. I don't think I said it in yours. But it was an issue during grading a couple years ago where somebody said negatively strong linear or something like that. And so because of the negatively, they didn't treat that as negative was the direction. And so that ly made it bad. So I might even take the relatively off just to make sure that I don't confuse my grader, okay? Larger implies that you are as a compare word. And so ERs are good if you want to compare things. Yeah, so right, so that can be an issue as well. So we have to make sure that if you are comparing, the ER must be there, right? Yes. Very strong would be perfect, yeah. But you can't say very linear. That wouldn't imply strength. And so some people were saying that, like very linear. We had a discussion about that. Would that imply strength? Probably not. So that's why you have to be careful about those kind of descriptions. So when I say strong, I mean that's the strength. Like, is it weak? Is it strong? Negative means that's the direction. It's either negative or it's positive. And linear is the shape. Okay, so you have to use those three words to describe their own situation. Okay, so based on the fact that it's negative, can't I cross these answer choices completely out, right? So I've given myself a 50-50 chance to get the question right, so that's good news. When you look at the picture, one has a pretty weak correlation and one has a pretty strong correlation. So looking at the picture, what would you say? A, and that's why A is the answer. Okay? I would hope they wouldn't say negative 0.9 and negative 0.8, because that would be very hard for me to decide. Okay, and they wouldn't do that to you. They would make it an obvious answer choice like they did here. All right, any others from bivariate data? We're good so far? Okay. All right, so the next big unit that we're going to talk about has to do with observational studies and experiments. Okay, so one of the things I want to make sure that we can differentiate between an experiment and an observational study. So let me turn these lights off so we can kind of, because these pictures, I used my camera to take pictures of the workbook, and I don't know that is that better? Can you read them a little better that way? Okay, good. What is the big difference between, and first of all, well, what's the difference between the two? There is one thing that distinguishes them that you want to look for. Do you remember what it is? One thing an experiment has that an observational study does not, always. Yes, but it's not the one thing that it will always have. A good experiment should have controls, and we're going to talk about what makes a good experiment, but you can still have a bad experiment. Any experiment, good, bad, or otherwise, has to have a what? No? It's a treatment. Okay? So every experiment, good, bad, or otherwise, always is going to have a treatment. Okay? It's something, you have treatment groups, and you give a treatment to one, not a treatment to others, or a different treatment. There's some kind of thing that you are giving to your subjects, okay? Your observational or your units of study. An observational study does not have a treatment, and that is really the difference that distinguishes the two. No, you're just observing something that's already in existence. You're not giving it, you're not imposing a treatment on anybody. Okay? Now, when we talk about, let's go kind of take a step back for a minute. When we talk about experimental design, sorry, I'm trying to get, there we go. In experimental design, good experiments have several things, right? We know that they have a treatment. We know that they're going to have that, because that makes it an experiment. But there are always 3, sometimes 4 things that makes a good experiment a good experiment. Remember what they are? Control is one of them, okay? So we'll write that. So control group. Remember, you have treatment groups in an experiment, and if it's a good experiment, one of those treatment groups will be a control group. Control groups are given things like a placebo. Remember what a placebo is? It's a what? Okay, it's a sugar pill. It could be a pill if it's a pill that we're looking at. It's just a fake treatment, okay? So it's a treatment, it's where people think that they're getting an actual treatment, but they're not. And so pills are oftentimes thinking of placebos, but it could be other things as well. Give me another good experimental design feature. Well, that's really what a control group is. Randomization, yep. And what is random? The way what? Exactly, the way that they're assigned to their treatment groups. So we'll say random assignment to the treatment groups. Because if you remember, you can have volunteers for an experiment, right? That's not the randomization part. In an observational study, you're going to go and randomly ask people questions, or you're going to randomly go and pick people, or you're going to not be the man on the street and just kind of ask people that happen to show up. But, but in an experiment, you can have volunteers, but you're going to randomly assign them to treatment group. There's one more thing. Nope, that's something totally different, but we're going to get to that too. So I'm going to write down here blinding so we can figure out what that means. Blind is not always possible, so we don't even put it here, okay? But blind is something that we want to consider. It has to do with the number of people in each treatment group. Shouldn't you have more than one person in each treatment group? We called that replication, if you remember. Okay, so I'm going to write replication, but basically it just means you want to have enough people in each treatment group to really measure and see if it's a thing. Okay, so we'll say numbers in each treatment group. Okay, the last one we can sometimes do, not always, but oftentimes blocking is something that we will do in good experimental design. What's blocking? Here's an example. I want to decide, whoa, that's not what I wanted to happen. I want to decide if a certain treatment group is going to be effective. So I'm going to do this. I'm going to block by something, and then I'm going to give a treatment and a control, a treatment and a control. I'm going to randomly, not pick here. I can't yeah, I'm actually going to. Well, no. What goes here and what goes here? These are the 2 blocks, okay? I could block by gender, that's common. I could say, okay, because the way that males and females might respond to a specific treatment might be very different. So I could block by gender, I can block by age, I can block by lots of things. It's a characteristic that makes that people in this group are alike in some sort of way, okay? People in this group are alike in some sort of way. So you block by whatever that characteristic is, and then you decide randomly at this point, right? I can't randomly pick whether they're a male or a female. That doesn't happen. But I can randomly take my groups of males and females and decide whether they got the treatment or the control. Okay? So that's what blocking is. Remind me, because Lily brought it up, what this idea of blind means. Go ahead, if you remember. Right. So blinding would be like if you looked at this picture, the people here and the people here don't know if they're getting the treatment or the control. That would be a blinded experiment. Okay, so it's blind if the people receiving the treatment don't know what treatment they're getting. The example I used in class, which was like the losing weight one, where you were on Weight Watchers or Jenny Craig or I don't know what else have I been on, Nutrisystem, I've done them all. That would not be blinded because you know what treatment you're doing, right? You know whether you're on Jenny Craig or you know whether you're on Nutrisystem, right? So that couldn't be blinded. But an example where you're taking a pill is a common example. Could it be a sugar pill or is it an actual treatment and you just don't know? That would be an example of that. Okay, blinding. Double blind is when what? Let's go back to the pill example. Not the testers, but the person giving it to you. You're getting the blue pill. You're getting the green pill. I don't know if the blue pill is the treatment or the green pill is the treatment. I'm just making sure that you're getting the blue one and you're getting the green one. Somebody knows, but it's just not the person giving it out. Okay? Good. All right. Here's an example of something that we know we've said, that causation can't imply, can't be inferred. What do you mean by causation? What does this word causation mean? And why can it not be inferred from can it be inferred from an experiment? If you did an experiment, can you say that this causes this based on the results? Yes. Okay? And an experiment is the only way that that can happen. Only way. Remember how we talked about correlation? And if things are really correlated, does that mean that one causes the other to happen? No, because remember firefighters? The more firefighters that show up, that means that the strength of the fire is really strong. But firefighters don't cause fires, right? One doesn't cause the other to happen. It just means that there is a reason that they're there. Well, because they put them out, right? So correlation doesn't imply causation, but experiments can. And that's the only thing that can. So experiments will make this happen. As long as the experiment is well designed. Okay? As long as it has a control group, randomization, replication, possibly blocking, then it can show causation. Okay? What's a census? That's an easy one. It's when you ask everybody in the population, right? Everybody gets a voice. Everyone gets to be known. So that's a census. SRS, you better know what that is by now. What's an SRS? Simple random sample. How, I can think of two ways, honestly, that a simple random sample can occur. Give me the two ways. There's really only two. If I put everybody in the population, like in the calculator, like if I know that there are, like I think back to that SAT example, right? All 303 people, and I did an SRS because I counted 1 to 303, and I used my calculator to randomly pick. What would be the only other way that I could do an SRS? It doesn't happen very often. I think the example I used in class was the Vietnam War, if that sounds familiar to you. Back in the Vietnam, that you had people who literally wrote their name on a piece of paper and you turned it in and they put them in these big barrels and they spun the barrels and then they drew names out of the barrels and read them over the radio, and that's how you were called whether or not you went to the Vietnam War. Putting people's names in a hat and drawing them is the other example of an SRS, okay? As long as you mix them up. Because at the beginning of the draft, they didn't mix them up and just the last people's names got put in and they had to go to war and they couldn't figure out why that happened because you got to mix up the names. All right, other kinds of sampling. Again, we're away from experiments now. Okay, experiments was this situation where you're imposing a treatment. When we're talking about observational studies, there's ways to collect data. An SRS is one of them. A census is one of them. What's stratified random sampling? What is meant by stratified? No, think it's not experiment, and people get this confused sometimes because it kind of looks like blocking, right? You think about it as blocking in an experiment, but blocking is you're putting people together that are alike, and then doing treatments from there. And when you're asking, like I always think of a survey. You're asking a survey a question. Why might I want to do random stratified sampling? I want to make sure I get some from each group. Okay, so if I wanted to do a survey of, I don't know, Stonewall Jackson High School students, what might be a way that would be important to stratify my sample? Which kind of groups? Grade level would be I want to make sure that freshmen are represented, that sophomores are represented, that juniors are represented, and that seniors. So that would be a reason to stratify. Okay, there has to really be a reason. I want to make sure that the reason I stratify is to make sure that every group is represented. Okay, that's the reason. What's a cluster sample? Let's think of a different word when I say that. So I don't pick a group of people. So it's not like stratified where I'm just going to pick only the sophomores and ask all the sophomores. The cluster should be representative of all the groups, okay? So I am going to pick one thing, but in that one thing, all the groups would be represented. So an example what might be if I want to make sure I ask kids in Prince William County or high school kids in Prince William County, I could pick one high school and ask everybody in that high school because they would all be represented. Okay, so I will say one group, would that be a way to say it? So one thing, I'll say one thing, high school, whatever, where all groups are represented. Okay, and then convenient sampling, which by the way is, never want to do it. Give me an example of convenient sampling. That's a source of bias, and we're going to talk about what the bias is. Convenient sampling definitely has a ton of bias, but that's not, you're headed in the right direction, but that's not the kind of sampling. Go ahead. No, go ahead. Yeah, it's like the man on the street. Whoever's available. I ask people in my class because they're convenient to me. I'm on the bus and I ask everybody on my bus just because I don't want to go out of my way because it's annoying, you know, whatever. And so convenience, I say man on the street because anytime that news reporters ask people questions, it's convenient to them. Like if I wanted to get somebody's opinion on gun control and I went to the NRA because that's convenient for me, don't you think that's going to introduce bias? Not necessarily, because it depends on your location. It depends on the time. It's not random because everybody doesn't have a likely chance of being selected. If I went to a school and I stood in the school and I went to the gym lobby, I'm not sure what she's doing, but if I went to a school and I went to the gym lobby, y'all might get pizza, I think is what she was counting for, by the way, because we're doing SOL review for math. And I'm always like crying over here. So I'm like, what about my AP kids? Because they need. Anyway, I think you're getting pizza. Thank you. Just like that's not fair. Anyway, back to your question. Sorry, Davis. I got distracted by pizza. If someone came to the school to ask high school students, and I stood in the gym lobby, and I asked people, don't you think 9th and 10th graders are going to have a larger chance of being asked that question because they have gym? And 10th, 11th, or 11th and 12th graders probably won't get asked. I knew you were going to bring on pizza. Thank you, thank you. Go. I'm going to pause the recording. Go get y'all's. Now, to go back to kind of where you were going, April, with the direction of bias, because all of these things, if they aren't done correctly, really do lead to bias. So let's talk about the different kinds of bias. And this is I feel like I'm in an English class sometimes because there's so much vocabulary, right? And this unit specifically has so much vocabulary. So let's just kind of make sure that we know what the vocabulary should be. So what's under coverage? Let's just refresh our memory. Do we remember? That's fine. Give me an example. That's actually a different one. Okay, that's actually going to be something down here, but we'll talk about which one it is. But under coverage is when a group is not represented. Okay, so it goes back to the example I was talking to Davis with. If I wanted to ask all students at Stonewall Jackson High School when I went to gym classes, the 11th and 12th graders wouldn't be represented because they don't take gym. Okay, well, unless you're, what is it, weightlifting? I forget which one it is. But very rare, they would be under coverage because of that. So that's when one group's not represented. I'll just say one or more groups is not represented. There we go. All right. I'm going to go to response bias next. What is response? We'll come back to non-response in a minute. What's response bias? The wording of the question influences the answer. So if I wanted to know your opinion on gun control, and I'm like, Corinne, do you have a weapon in your home? Do you have, what do you do? Do you want to go shooting on Sunday? I don't know, right? I mean, I'm just saying, like, the way you ask the question is going to influence the response you get. So that's the most common. So wording of the question is a response bias situation. What's non-response bias? That's voluntary response bias, which is not listed here for some reason. But voluntary response bias is when you volunteer to either answer or not to answer, okay? So that would be like you hang up people's political phone calls. I just can't wait for this summer. Come October, they're going to call my house 5 times a day. Was it this year when people were trying to drive me to the polling station this year? Yeah, it was this year. Yeah. No. We'll drive you. We'll come pick you up. Is that legal? I guess it is. Anyway, that's usually the phone call thing where you can hang up or whatever, or you can fill out. This is where you were talking about. You can fill out at the restaurant how was my service? How am I driving? The bumper sticker on the back of the car. You're only going to call if the guy cut you off. You know what I'm saying? You're only going to fill out the card if you have a very strong opinion. That's voluntary response bias. What is non-response bias? Yeah, when a whole group of people just don't respond to a question. Okay? Oftentimes these two are kind of related because if you have non-response bias, isn't it going to be under coverage too? Right? So they kind of go a little bit hand in hand. But non-response is when a whole group doesn't respond to a question. And they might do it kind of like, I don't know. I yelled at the juniors, or I yelled at the seniors for wearing togas because I think it's inappropriate for you guys to like show skin. So I didn't like that. So I said the seniors and I yelled at you guys. And then I wanted to ask a question of all the students at Stonewall Jackson High School, and the senior class was like, well, I'm not answering your stupid question because you're like you yelled at me. That would be non-response bias because that whole group just was like, you know what I'm saying? So that would be an example of that. We know experimental design. We talked about it, but we didn't talk about the vocabulary with it. So explanatory variables, what? And response variables. What's the difference? That goes with your independent, dependent, the thing we were talking about before. One means independent and one means dependent. One means X, one means Y. This is Y, this is X. Does that help you with independent and dependent? Which one's independent? Huh? And this would be dependent. The response is dependent on what you put in. Statistics always has to throw in their own vocabulary word. Why can't they use independent and dependent? Because they have to be different. They mean the exact same thing. Okay? Totally the same thing, just a new word. Thanks, statistics. When they talk about levels and factors, Do you know what they mean? Let me use an example. What if, I'm trying to think about examples I've used in class. Plants. I'm trying to grow plants, okay? I don't know, I'm into, what's a good plant that grows quickly? Corn. I'm going to grow corn, okay? It grows quickly for a short period of time, and I want to make sure that I want to harvest the most corn. Fine. There are different things that would come into play. I'm going to talk about light, the amount of light exposure they have, the amount of water that they have. We'll just do light and water because I'm a organic feeder. I'm not going to feed them anything because I don't want to ingest any chemicals. So I'm just going to worry about light and water. Let's say that I'm going to expose some to light by a window and I don't know, closet, yeah, dark. And then in water, I'm going to look at 1 time a day versus 2 times a day. Okay, so those are kind of my situations. So tell me what is a level, what is a factor? How many factors do I have? 2. And what are the factors? Light and water. Okay, so these are my factors. What are the levels? Would you agree? Each of the factors have 2 levels. Okay, so if I wanted to figure out how many treatment groups I needed, okay, I'm going to put where they have by a window and then by a closet. And then I'm going to look at 1 time a day, 2 time a day, 1 time a day, 2 time a day. Would you agree with that? Has that accommodated everybody? So I have 2 factors, 2 levels. How many treatment groups do I have? 1, 2, 3, 4. Okay? And that's how you would find that. You sure? Okay. Just making sure. We know about randomization. Why is there a need for a control group? Why do you need one? Why would it make it more accurate? I agree, but why would it make it more accurate? Say it again. Compare and see and measure their effect, right? You can compare the treatment groups, and that would give you an accurate result, right? So you want to take whatever your treatment group is, compare it to the result, and find the difference between them and do a measure to see, oh, I did get bigger corn with this or whatever. Okay, good. Let's see if we're almost done with this particular. We're about running out of time for me. Placebo. We talked about being that as a fake treatment. Sugar pill is a common one. Can you think of a different scenario where you'd have a placebo and it's not a sugar pill? The boots. Give me the example of the boots. What do you mean? Was there a placebo, though? I think that was blinding. I think you weren't sure which one got the waterproofing treatment. I think that was a blinding, not a placebo situation. I'm trying to think of a fake treatment. I don't know. I mean, I could use an example of the boots. I have something in it, and I rub it on the boot, and you don't know whether it's waterproofing or whether it's just nothing. I could pretend like that happened. That could be an example. But if you just remember that it's a fake treatment, not necessarily always a sugar pill. There could be other scenarios. We've talked about single blinding and double blinding. We've talked about blocking. When we talk about matched pairs design in terms of an experiment, we did a matched pairs t-test when we did a hypothesis test. And we kind of referenced it a little bit, but I didn't really make a strong connection between the two. What is a matched pairs design from an experiment? Give me an example of something that might happen with matched pairs. Remember that in an experiment you have treatment groups. So what kind of treatment groups am I going to have with matched pairs? There's another name I use for it a lot, or I have said before. I say it a lot with my head, but maybe not out loud. You heard me say before and after? Before and after design? I've never said that out loud. Wow, okay. Well, I have today. So before and after design, same thing as matched pairs. Or it is a type of matched pairs. Might be kind of like you want to measure the person before they go on a weight loss program, give them a treatment of a weight loss program, and then measure them after it, and you want to see the results and compare. That would be a matched pairs design, okay, before and after. What would act as the control in that group, in that situation? The before would be the control, okay? So, good. With a matched pairs t-test, we know how to do that. We'd have the same person, measure them before, measure them after, and then I would subtract the two, and I'd be dealing with just the differences. So that's how the two are going to kind of relate to one another. Replication, you need more than one person in a treatment group because there's going to be variability, there's going to be errors, there's going to be situations, so you need to have multiple people to get a good, clean result. What extent of the result of an experiment can be generalized to a whole population? What do they mean when they say that? What do you think they're referring to? Yes, obviously the amount of bias you have is going to affect that. Also has to deal with populations. Like if we're talking about students at Stonewall Jackson High School and we do an experiment on them, would it be fair to take my experiments from Stonewall and say that there's true for all students everywhere in the world? Why might that not be a situation I could do? Why would that, if I wanted to generalize to all teenagers, why taking one sample or one experiment from Stonewall students, why might Stonewall be different than everybody else? We live in Northern Virginia. Let's start there. Okay, in Northern Virginia, are we maybe possibly more educated than, let's say, Ethiopia? Okay, or a third world country. Wouldn't you agree? So it'd be hard to say age group wise. You'd have to be more specific. So when we talk about generalizing to the whole population, you want to think about what population are you talking about? All students? All over the world? Like, just be careful about who you're generalizing to is really all they mean by that. Okay? And I think I'm going to stop there because probability is the next big unit. So, and that is something that we're going to spend next Wednesday on. And when we get to that, we're going to, because I just counted, and when we get back from the beginning of the fourth quarter, we're going to take a test that first day. But after that, we have 8 class periods before your AP exam. And so I plan on spending, there's 4 units, 1 day per unit, do a practice exam. But I think we're going to spend 2 on probability because I think we need to. It's been a while, and we're going to need to do that. So next Wednesday for sure after school we'll do probability, but we're also going to do 2 in class as well. So let me go ahead and give you some problems to look at from the book that deal with that deal with experimental design. So we're going to start with exam 1, and I want to make sure that I am looking at that. So sample exam 1, you're going to do problem number 2. (14), 17, 29, 32, Da-da-da. And we're going to stop there for sample exam 1. I'll give you a couple on a sample exam number 2 as well, just to make sure that we're clear. Well, actually, let me see real quick if there's any free response questions. Yeah, let's look at sample exam. Well, that's the multiple choice section. On the free response section, on sample exam 1, I want you to do number 2. Okay, so we'll just stick with sample exam 1 and give you a free response to look at, as well as some multiple choice. Okay, perfect. All right, guys, we will see you in class tomorrow.